So now we are actually going to see some basics of Golang. Okay, and these basics we are going to see with the fact that, or with the perspective that you are somebody who already knows some programming language. Okay, so the requirement to understand here are going to be the fact that you already know some high level programming language, right? For example, if you know something like JS, C++, Java, JavaScript, uh, TypeScript, all of these languages, you will be able to, let's say, get a lot of things very easily. If you don't know about anything about any high level programming language, then I would say that what we are going to discuss, you might need to go slightly in a bit more in depth of that, right? Try to practice more algorithmic stuff around with Go, but we'll still see a lot of basics of Go. So this is the only requirement that you need to have. Now, additionally, you also need to install Go in your machine, right? That you don't need to do now, because there is something called as a Go playground. Go playground, if you will search, then it's kind of like an online platform which is officially given to us by Go, where we can just go and like write some code and technically execute it right here. So if you click on run, you can see you'll be able to directly execute it here. So it's kind of like a good head starting platform given to us, but eventually you would like to install Go at some point of time in your machine, right? So you can go download Golang, right? And you can check, let's say for Windows, for Linux, whatever you want. So you can see download and install Go. If you have a Mac, then you can download Go like this. If you have a Linux, there is a separate set of commands and a separate downloader package, and for Windows, this is the corresponding package, right? So you can just go to this URL, go.dev/doc/install, and from here you will be able to technically download and install Go in whatever machine you are actually more comfortable with, right? So you can just go and download it for your machine. There we go. Okay, cool. So that is going to be something that we are going to that you can separately do asynchronously apart from following these lectures. But before I start writing the Go lang code base, and before I start giving you explorations about Go, I would like to talk about some of the interesting features that made me fall in love with Go, right? I feel like Go is one of those modern programming languages that actually solves a lot of problems that other languages at some point of time definitely get. Okay, so let me start talking about what are some of the features of Go. Because if you know about features of Go, you will be definitely excited to learn about Go. First, I believe syntactically, syntactically, Go is simpler than a lot. So, before moving forward in the video, if you're somebody who is actually looking to learn Spring Boot and want to develop a career in backend development in Java, then you are at the absolutely right place. So now we have actually launched the second iteration of our Spring Boot cohort, where we are going to talk about a lot of interesting backend development topics in Spring Boot, right from the beginner level to the very advanced level. We're going to start with basics of what is a build system. We'll start learning about what are basics of databases, what are basics of Spring Boot, and slowly and steadily we'll move to advanced topics like how you can actually implement distributed transactions using the saga design pattern, be it the choreography saga or the orchestration saga. We are going to talk about the design aspects of some of the very interesting projects, including making a distributed wallet, including making an Airbnb based backend booking system. We are going to talk about how you can actually play around with geospatial indexes and how you can make an Uber booking application altogether and whatnot. There's going to be a lot of important topics that are very frequently used in day-to-day backend engineering job, which will actually help you to get the idea of what exactly it looks like to develop these kind of like scalable applications. So if you want to turn up your portfolio into an absolute Spring Boot beast, then do check out the link in the description section below and use this coupon code to get maximum discount off on the cohort. And I'm really excited for you to join the cohort as well. So let's just resume back to the video. Of languages. Like for example, if you just see a basic hello world code, this is the only thing that you have to do for a basic hello world. You don't get started with classes and all. You don't have to write a like a very big class. You don't know about what are classes. Still you are able to go with Go because it's very similar to your early days fundamental languages, something very similar to C or Python. Like in a lot of schools, in a lot of colleges, the first language that is taught a lot of places, 50 to 60% of the places, is either C language or Python, right? In both of those languages, if you have to get started with the things, you will see something very similar. For example, hello world in Python. If you see a hello world in Python, it's kind of like a very straightforward and a very simple code, right? This is the only thing that you have to do in Python. But if you see things with, let's say, Java, you have to slightly write a bit more code. And you will see this thing throughout, that Go has a very minimalistic syntax. It is easy to read and write. And for even for beginners, it's not going to give you a very hard time, at least what I believe. Second, which is kind of like a very interesting support, is that Go is a compiled language. Now, I don't know how many of you guys have actually ever seen the benefits of compiled languages, but what I believe is any compiled language, like what makes a language compiled, that you are going to read or parse the complete code and find out errors early, right? That's what compilation can technically do for you, right? So technically you are going to write some Go code, you are going to then compile it into an executable, and then you are going to technically run that compiled code, because of which Go automatically becomes faster than a lot of other languages compared, if you do a comparison with something like Python, Ruby, JavaScript. Being a compiled language, it's faster than that. Let me show you a metric. So if you go to, let's say, Hacker Earth language times, okay, so if you see the judge environment timing, so like this is a page which actually shows, which is very much consistent to other online judges as well, that let's say a judge, how much time and memory it gives for one code and compare one language, and compared to that language how much it gives for others. So if you see, like if you are writing a code in C++, right, then if let's say you have been given a time limit x, assume that time limit x is 1 second, then in languages like, let's say, Go, you are just given 2x, which is relatively good, right? It's relatively faster, very similar to that of Java. You can see Java also get 2x time. But if you see something like Python get 5x of the time, right? If you see something like JavaScript or TypeScript, you are going to again get 5x of the time. So you can see already, like in terms of online judges as well, writing code with Go in online judges also is going to give you a very fast execution altogether, which makes us come to a discussion that what about the comparison between Go and Java? Like, do you think Java is better than Go, or do you think Go is better than Java? What do you think about it? Right? For that, there is another feature that is going to technically blow your mind. Go has a very crazy, I would like to write the word crazy, concurrency support. And how it actually achieves it? So, Go has a concept called as Go routines, which is nothing but a lightweight thread. So threads are already lightweight processes. You have even one level lighter weight concept called as Go routines, right? So this is kind of like a inbuilt concurrency support that you're going to get with Go, right? And there are a few more concepts that complement Go routines, like channels, which is going to help you write concurrent code, which is very efficient and very safe. This kind of like starts making Go slightly a bit more better when you see or compare it with things like Java, right? Go routines are kind of like lightweight threads, and don't worry, we'll be going into the concepts of that, but you will be able to use it to perform tasks concurrently. And there is something called as channels, which can help you to make two Go routines kind of like communicate with each other safely. So that's also kind of like a very good benefit. But apart from all of this benefit, there is one interesting feature that comes out of the box in Go, which is not present with, let's say, things like Python, JavaScript, Ruby, which is type support. So Go is statically typed. What do we mean by that? Go is technically a type safe language. It is a statically typed language, which means that there is a type system that checks the variable at the compile time rather than runtime. So all of those type related errors you will be able to catch as early as possible, right? Interestingly, now if you start comparing it, you will be like, okay, but it's still slightly slower than C++, right? But there is a very big problem with C++ that C++ don't have their own garbage collector. So if you see garbage collection in Go, what you will realize is that Go language takes the responsibility of arranging the storage Go values, right? And here, if you search about garbage collection, another term for automatic recycling memory is garbage collection. At a high level, a garbage collector or GC is a system that recycles memory on your behalf. This is something that you have to manually do in C++, right? The Go standard toolchain provides a runtime library that ships every application, and this runtime library includes a garbage collector. So you have a garbage collector also out of the box, right? Garbage collection support. You have a garbage collector also out of the box that also is going to complement everything here, right? So this is going to be very interesting to actually see. And apart from that, Go, again, Go is slightly a bit relatively new, but the overall, I would say, library, the standard library support and the third party library support is also increasing day by day. It's open source. Go is an open source language, so you will see a lot of community contribution coming up here. It's kind of like very primarily focuses on a lot of functional programming concepts. So any functional programming concept that you might have seen in, let's say, things like JavaScript, like closures and all, you will find similar concepts coming up here as well, and more. The ecosystem is growing. A lot of big companies are making production ready code with Go. Companies like Google, of course, a lot of products in Google are written with Go. Uber is kind of like one of the biggest consumer application that works on the back end of Go. There are more companies which have started migration their code bases to Go, right? You'll find tons and tons of Indian startups, startups in US that are very heavily relying on Go. So these are some of the like interesting features, and the feature list goes on and on. It's cross-platform also. So interestingly, it can be compiled and run on multiple platforms, right? So that is also kind of like a very good support that you get, right? Which is technically not present in C++, right? So and now if you see the performance comparison, if you see performance comparison of Go and Java, right? So so you can see in terms of the performance, generally Go outperforms Java in things like web serving, which is going to be something primary that we are going to see, CPU bound tasks, and latency sensitive applications. Go's efficiency stems from its compiled nature, lightweight concurrency, which is Go routines, and optimized memory management. Right. So this is what makes kind of like Go slightly a bit more faster than Java as well. So, and if you compare that, so now in order to get started with Go, again you can separately go and install Golang in your machine. But what I believe is, just to get the syntactical idea of Go, a very good way would be the Go playground. Here you can just come up, write some code, and technically run it, and this will actually give you the corresponding output. So we will do some playing around here and there with this playground only. Okay. What you will actually realize is that this is kind of like the most simple fundamental code that you can write in Go. Okay. If you see this, then there are technically three parts of this particular code that we can go through one by one. Technically there are four. There is some comments here also, so you can see if you want to write comments in Go, you can just put a pair of double forward slash, and this can help you to give some comments. For now I'm removing all of those comments. So what you will realize is that in this simplistic code there are three main parts. One is called as func main, one is called as import fmt, one is called as package main. Let's go through all of them one by one. What is this func main? So func is a keyword in Go that can help you to define functions. Very similar how you write functions in JavaScript, for example. You can write func as a short form to function, and then give a name of the function, put a pair of parentheses. If you want to define any set of parameters, you can define in this pair of parentheses. And then inside a pair of curly braces, you can open a function block and write a logic for a function. Now interestingly, in a Go code, there is a main function very similar to a main function in C++, very similar to a main function in Java, right? Which is kind of like the entry point of your code. If your code has to execute, there needs to be kind of like a main function altogether, right? This is what you have to technically keep in mind, right? So now you can see this kind of like directly runs the code here, but I would like to also show you the Go code running on a machine, like locally. If you have to run a code, how you can do that, although majority of the time we are going to spend in the playground, but I would like to also show you a local implementation as well. For example, or maybe we can also spend time on the local machine, no worries there. I can make a folder, Go basics. Okay, I'll open this in VS Code. So in my machine, Go is technically installed. Okay, let's make a new file, hello world.go. Okay, hello world.go. Cool. Now let's copy paste this complete code that we got here without much of a thought. Let's copy paste and then we'll see what is technically going on. Okay, you can see I've pasted the complete code. Now if I have to run this code again here on the online platform, you were just clicking on run and it was running. But let's see how you can actually run the code like in your local machine, where you don't have kind of like a GUI support. How can you run a Go code? So in order to run the Go code, assuming that you have Go installed in your machine, the simplistic thing that you can do in terms of command is that you can just say go run and then you can give the name of the file. So this is hello world.go. The moment you execute it, you can see you are going to get the corresponding output. Now you might feel that, oh, we didn't do any compilation and it is very similar to that of JavaScript, but that is technically not the case. Cool. So this run command, if you see the go run command, this is technically doing both of the things for you. It will compile the code as well and then run it for you also. But let's say if you just want to compile the code, do not want to run it and just get the executable binary. How can you do that? So very simple command. You can say go build and you can say hello world.go. You can see there is kind of like an executable file that it has technically created, and now I can execute that file. I can say hello world and you can see this was an executable and we are able to technically run it. Moral of the story is that you can just compile the code also, or you can just give this responsibility to Go that please compile the code and run it for me. I don't want to see the executable file separately being saved. I just want to see the final executed output. That also you can technically do. So these are kind of like the most basic things that you can get started with. But in order to do that, there should be a main function. You cannot have a function, let's say fun. Let's say like you can have a function fun, but the interesting thing that will happen here is if you try to do go run, you will see that there is kind of like an issue coming up, that there is no function main in this particular file. That means it's not able to find an entry point. The moment you define a function main, and let's say from your function main you call another function. How can you call another function? Just type the name of the function, put a pair of parentheses, and that's it. The moment you do that, everything is fine. So you need to have in your complete project, you need to have a main file which is going to kind of like execute the complete go code for you. This is slightly a bit different than JavaScript if you see, but if you compare it with other languages, it's very much consistent to things like C++, C, Java, C Sharp. Those kind of languages have kind of like very similar concepts like this. Now, just like, so I'll just revert all of this code back. Now, if you see, there is one more statement coming up called as an import statement. Again, very simple line of code, very similar to other languages as well. If you want to import any particular package, right? Package you can say is kind of like a library that you create which has some functionality written by you, or it can be a third party library as well. So in the world of Go, we call these kind of libraries as packages. Okay. So if you want to import any package inside your code base, you can do that with import keyword. As simple as that. So that's what this import is doing. And if you see, there is something called as package main return here. This is kind of like defining a new package. It's kind of like defining a new library for you, right? So you are defining a new library named as main. Okay. You can name it something else. For example, let's say, let's try to name it like Sanket, package Sanket. Okay. If you will try to run it, then what you will realize is that this is again causing one small issue for you, that the moment you try to run the code, it's again asking that this is not a main package. So this leads us to one more conclusion for us, that your final executable should also be coming from a main package. You can define other packages, import that into your main, but your final executable will be coming only from a main package. So we'll see how exactly kind of like the main package is different than your other packages. For example, if you go to import fmt, you can hover on this and you can see this fmt package has a name on the top called as package fmt. So we are able to import it. Similar to this, we will be able to create our own packages as well. But your final executable should be triggered from a package main only. And you can read about this error as well. So if you will copy this error and if you come up to this, your code is not in a package named main. Use package main as first line, right? So this is kind of like a very simple concept in Go, that your starting point should be kind of like a main function from a main package, and you will see things unwrapping one by one like an onion, right? But this is kind of like the simplistic Go code that you can get started with. But of course, there is no fun in a programming language without actually introducing any sort of values, right? So we'll see what kind of values and operators it actually supports. It has a good wide variety of supporting values and operators that we are going to see. So now Go has wide variety of values that you value types available that you can actually create. You can explore about the values, but like for example, of course, you must be able to see that if you want to print something, you can write fmt.println. This is a statement that can help you to do printing. Okay. Now you can see there is the first type has been already introduced to you, which is kind of like the type text, or you can refer it as a string. So any random text that you want to write, you can wrap that in a pair of double quotes. Now, what will happen if you wrap it in a pair of single quotes? It is not going to work. Here, double quotes only are going to technically refer to a string. And you can see this is kind of like an illegal literal. You do not have a literal like this, right? So this is something that you have to keep in mind. But in single quotes, you have a new interesting type, right? You can see if you have a single character, the moment I make it two characters, this is going to start making an error, because a bunch of characters is what? A string. But if you have a single character, then you can define a single character using a pair of single quotes, right? Now, apart from like strings and characters, you can have, let's say, numbers. So let's say number like 12, or maybe like I would say floating point values like 12.89. You have booleans available, true, false, all of this is available. And again, you can see you can configure the Golang extension in VS Code so that it can tell you compile time errors directly in your editor, so you don't have to technically waste a lot of time there, right? So it has a lot of value support available, right? You don't need to remember all of the values. You can just search for Go types, basic types, and you can see there are a lot of basic types available. You have boolean, you have string, and interestingly what you will see is that there are different type of integers. Now what is the meaning of these different type of integers? Now what happens with Go is that Go is a compiled language, right? Now if you are somebody who is coming from the world of, let's say, JavaScript or let's say Python, then the size of the bucket in which you want to technically store the value, right? What is the bucket in which you store the value? That's a variable, right? Variables are those buckets, or I would say the label of the buckets in which you store the value. Actually, the values are stored like this. Like for example, if you say something like x is equals to 10, so in the memory, what do? You create a bucket. Inside that bucket, you put the value 10, and then you give name to this bucket. Let's say x. So here x becomes what? A variable. Here x becomes a variable. Variable is nothing but a labeling that you give to the bucket in which you are going to store the value, right? Now here, for optimizations, you cannot just have any type just stored in any variable, right? That's the benefit of statically typed languages. In statically typed languages, what happens is that you have to define the type of the bucket earlier, and based on the type of the bucket only, you will be able to store the value. For example, You have int 8, int 16, int 32, int 64. What first of all this denotes? This denotes that there are different type of ints available in Go. But you might be familiar that okay, int is something just which is just a number, right? So how come int is different than int 64, or what is this int 32? This is technically representing that what size of integer you can actually store, right? Just think about it. When you store the integer 10, so actually eventually what is going to happen, this is going to take some memory in your machine, right? Now how much amount of memory an integer can take can be dependent. For example, let's say, just think about it, if let's say you have to store something like 10, how many bits you technically need, because eventually everything is going to be represented in the form of a binary, right? That's what we know. Eventually everything is going to be represented in the form of a binary. So if you have to represent 10, how many bits in kind of like the worst case you need? You just need technically 4 bits. If you have a memory reserved as big as 4 bits, then you will be able to represent 10. As simple as that, right? Because just think about it. If you have to represent binary of 10, you can represent the binary of 10 with just 4 bits, right? So depending on how big of an integer you want to actually store, you can decide which integer container you want to have. For example, int 64 means you can store 64 bits, right? You can store an integer which can be which needs to be represented by 64 bits. Now if you have a very big integer, then that very big integer will be required to be represented by 64 bits. If you have slightly smaller integer, then you can have a 32-bit integer container. Then you have a 16-bit integer container, you have a 8-bit integer container, and so on, right? By default, if you see, then this normal int, if you see, this normal int is going to take your platform default as well. So if your platform is a 32-bit platform, a lot of systems you will see that your system is a 64-bit system or a 32-bit system. So by default, this is going to take the bit size of your system. So if your system, let's say, is a 64-bit system, by default int will work as a int 64. But generally it's good to manually represent that, okay, what will be the size of the integer. Okay, this is also something which is going to be very important. And these are signed integers. Signed integer means that within these 64 bits you have to represent both negatives and positives. Now you have something called as uint as well, right? What is uint? So uint in Go, uint is kind of like unsigned integer. Unsigned means that you are going to only store positive values. That's what the representation of u is. Now the benefit of u is that you are able to kind of like store double values, double the size, right? So if you see, let me show you. So range of values that can be stored in 64-bit integer versus 64-bit unsigned integer. Okay, let's see. So if you carefully see, in a signed integer means you have negative and positive both. That means you have signs. You will be able to store maximum, this is the biggest number that you can store, 2 raised to the power 63 minus 1. But if you have an unsigned 64-bit integer, you will be able to store 2 raised to the power 64 minus 1, right? This is the benefit. So at any point of time, when you know that the value you are going to store can never be negative, right? Let's say, what can never be negative? Let's say the final amount of an invoice can never be negative. You are going to purchase something, the value of the invoice will be either 0 or more. So that value you can store in an unsigned integer altogether, right? So again, this is generally given for more, I would say, specific, I would say, type implementations, but this is something that you have to keep in mind. Okay, and then you can see, you can also store complex numbers, right? You will be able to store complex numbers. So if you want to store complex number, you can store something kind of like this, right? I have never seen in production use cases where we can store complex numbers. Interestingly, The only other language that I know, maybe there are more, I'm not aware, but the only other language that I have worked with that also supports complex numbers is Python, right? But I've never used seen a production use case in at least like web applications and products where I have worked, where you can use complex numbers, so you can explore. But of course, in mathematical applications, complex number is a pretty interesting thing to actually work with, and so on. So there are a lot of types available. You don't need to remember all of the types. Go is not one of those languages that is going to come in your college exams, or people are not going to give you MCQ in Go. Go is one of those languages that most of the time you will directly see working in production use cases. So there is not going to be a viva for you, so you don't need to remember all of this. It's just that Go also has a very verbose and very wide type support available that you can technically use. Now, we know what are these types, but definitely we need to actually put these types in a bucket and label those buckets so that we can refer them later. That's where we need the concept of variables. Now, how can you create variables in Go? Variables can be very easily created using the keyword var. So there is a var keyword. If you put the keyword var and then give the name of the variable. So let's say name of the variable is let's say product name, okay, space, and then you give a type of the variable, that what will be the type of this variable. So the type of this variable, let's say, is going to be a string equals to some value. So let's say iPhone 11. What this makes is, this actually technically makes a variable for you. Interestingly, what you might be able to realize is that you do not put semicolons. Like even if you put semicolon or don't put semicolon, it's not going to matter. If you have a linting tool installed in your machine, then it's going to automatically remove semicolons. Semicolons are not needed here. But what I want to mainly mention is that if you want to create a variable, where is the first way, or I would say one of the ways to actually create a variable in Golang, right? So where here is going to be a keyword. So where is a keyword. Where keyword can be used for declaring variables. Okay. After the where keyword, you have to give the name of the variable. This is your name of the variable name. Okay. And then you have to give the type of the variable. This is kind of like the type of the variable. And after that, you put an equals to, which is nothing but your assignment operator, very similar to what you might have seen in other languages as well, right? Assignment. And after that, you technically give it a value, the value that you want to put inside this bucket. Value. Okay, this is how you declare a variable in Go. Now, if let's say you put the type of the value variable as string and you try to put 10 here, you try to put, let's say, something like 10 here, you can see there is an error coming up. You cannot use a type 10 as a string value, right? You won't be able to do that. You can only put a string. And let's say, and you can see this is currently throwing you an error because this is technically not used. You have declared this variable but never used it. So if you try to run this code, you can see it will say that you have declared a variable but you have not used it. So let's use it. So we'll say fmt dot print ln, and we can say product name is comma, and you can put a variable name here, product name. Here we go. Save it, run it, and you can see product name is iPhone 11. So that's how you create a variable. And if you want to print a variable, and you if you want to print multiple things, you can put directly a literal here, then comma separated, you can put another literal, or you can put a variable name, anything that you want. Okay. Now what happens if you don't put a type here? If you don't put a type here, what you will realize is Go is not crying in front of you. Go says that even if you don't put the type of the variable when you're declaring it, I can infer the type. That means I can understand that this is the first time you're declaring this variable and you're putting a value of a string. That means you want the type of this variable as a string. So automatically, without you writing, it will automatically pick the type as string. You don't have to like manually mention it here. This is kind of like a shorthand. Now, this shorthand will only work if you are assigning a value. If you are not assigning a value, then you have just made a variable and neither you have given the type. nor you have assigned a value with which Go can infer a type. Hence, it will start throwing you error that it's a syntax error, expected some type. So now, if you just put the type here string and you don't give it a value, that's absolutely okay. It is going to give it a default value of that type. So the default value of string is empty string. Now here's a homework for you. Try to see what is the default value of integers, booleans, and other types in Go. That would be a good activity that you can have. Right? Try to explore what are the default types of other types or default values of other types available in Go. But my point being that this is one way in which you can just declare a variable, not assign any value to it. Then you can have, let's say, product price, for example, as a int is equals to, let's say, 1000, and you can say, and price is product price. And then another way would be where company name is equals to Apple, and you can say, and company name is Apple. Okay, so these are kind of like three ways in which you can actually implement things that you will be able to give. This is declare a variable to hold a product name but no value, is assigned. This one is declare a variable to hold the product price and assign a value. This one is also a variable to hold the company name, assign a value, but type is inferred. Inferred means Go is going to automatically understand the type. You do not mention the type here. Now, there is one more way. There is one more way in which you can declare a variable. This is an interesting way in which you can actually avoid the keyword var. You can avoid the keyword var, and it will be kind of like a shorthand for you. What is the way? Let's start exploring. So, I'll say a keyword, I'll say a variable name category, and then you can put a colon equals to, and then you can assign it a value electronics, let's say. What is this? In this way, you are actually declaring a variable to hold the category value, and you are assigning a value, and the type is inferred. That means line number 8 and line number 10 are exactly doing the same thing. You are not specifically mentioning a type here. Here also in line number 8, you are not mentioning a type here. You are assigning a value, you are assigning a value. And Go is using that value and inferring the type from that value. The only difference is here you put a var, here you don't put a var, and it's kind of like a shorthand. And a lot of times you will see a code like line number 10 coming up in front of you, where people just declare a variable with this shorthand. They don't want to use var. It's kind of like slightly a more shorter code, slightly a bit more self-explanatory code. So I can say category is category. The moment I do that, here you go, category is electronics, right? So this is something that you can actually do, and this is how you will be able to create variables in Golang. Now, Go also gives you support for creating constant values. What are constants? So once you assign a value to a constant variable, you will not be able to like change it. For example, let's say you say const. So there is a keyword called as const. Okay. You say const, and let's say availability, available stock, for example, available stock is equals to 50. Right. Now you can see I'm trying to create a const variable, but what you will realize, this syntax is not working. Why? Because if you are using const separately, you cannot use this shorthand. You can just do an equals to, just like you were using with var. Very similar syntactical sugar that if you compare that with JavaScript. And the moment you do that, you can see you have a available stock as 50. Now here, let's say if I try to do available stock is equals to 100. The moment I do that, you can see there is a compile time error coming up. You cannot assign a value to available stock. Why? Because it's a constant value. So you will not be able to update the value of available stock. But you can update the value of product name. So you can say product name is equals to iPhone 15 Pro. You can see no errors as such. So constants are available to you. If you want to put some, and like in production cases, in development scenarios, there is a lot of times that you might have to put constants in place. So if you have to put constants in place which you don't want, which are variables that you don't want to reallocate a value, that's how you can do that, just by using the const keyword. So now we know how to put values in variables. The next important thing that probably you need to do is conditionals and let's say loops, right? So for example, if you want to create loops in Go, so how you can create some loops? So let's see. I'll again say package main. For now, I'll just keep everything same, import fmt func main, right? We'll come to this concepts of packages and all once you have all the basics. So generally, whenever I learn a language, I try to divide the language into 4 to 5 parts. One is how to store values. Second is how to loop and do conditionals. Third is the concepts of functions. Fourth is the concepts of oops. Fifth is technically the concepts of making multiple file related project. That's how generally I distribute a language altogether. Okay. Now, interestingly, the moment I have made another file with package main and defined another function main, can you see it's throwing me an error? Why? Because in the same folder, you have another file of the main package. The moment on top of any file you define package main, this means that both of them belongs to the same library with the name main, or the same module with the name main, or with the same package with the name main. And in the same package, you cannot have two main functions. That's a problem. So let's say I define it as loops demo. Okay, you can see no errors as such. And for now, let's say if I say fmt.println loops demo. Now let's see if we can call this function from here. So if I come to this file and if I say loops demo, can you see no errors as such? And if I try to run the code, it says loops demo is technically undefined. Why it is saying loops demo is undefined? Because it's not able to directly locate exactly from which particular file you are trying to bring loops demo. So that's what we are going to technically see after some time, that how you can make a multi-file code, how you will be able to make a multi-file code. We'll see that, but you can see it's not going to throw you an error that like loops demo is kind of like out of your package, because as of now we have defined it in package main. If let's say we would have defined it in a different package, let's say lib, if we would have said let's say package lib, then we would have to make extra adjustments here, right? So we'll not go there. Let's do one thing. Instead of making a separate loops file, for now I'll put this function loops demo here in the same file. So func loops demo. Okay, cool. And now how can you make a for loop? Very simple. In for loops, you do not have to put any parentheses and all. Very straightforward for loop, very similar to how other languages have for loop. So if you want to create a for loop, you say for, you don't have to put a parentheses. Then you declare a variable. So let's say I. And if you want not to use var and you want to automatically go to infer the type, you can use the shorthand for I equals to 0. Then you put a semicolon, I less than let's say 5. Then you put a semicolon, I plus plus. So plus plus is going to be an operator, right? I plus plus. And then in a pair of curly braces, you can define a block and you can say fmt dot println loop iteration. And now you can just call this function loops demo. And you can see you are able to iterate to all of these values. This is very similar to how you create for loops in other languages. You have to define a starter value, you have to define a terminating condition, and you have to define a incrementing value altogether. That's how you can actually make for loops in I would say Go. Now Go also inherits the concept of for loops from some other languages like Python. So let me show you a few more ways in which you can put for loops in place. So there is something called as a range. Okay, so let me show you what is range in Go. Okay, so here you go. The range form of the for loop. So range is kind of like a way of writing for loop. iterates over a slice or map. Don't worry if you don't know but understand about slice as of now. You can say that range is kind of like an integral part of for loop, right? Range can actually help you to define a range of values. For example, if you say for I colon equals to range 3, something like this. And if I say range loop iteration I, let's see what is the output. Can you see? If you say range 3, it is technically going to make I iterate from 0 to 3 minus 1, right? That's what technically range can actually do for you. It's going to give you a range of values, right? And one by one, your variable is going to iterate over that range of values. This is kind of like a very fundamental concept, and it's kind of like a shorthand. And similar shorthand you will be able to see in other languages. For example, let's say Python. Python also has similar range related concept. Actually, range is doing slightly a bit more extra, right? For example, you can put range like this also. So for I range Sanket, if you say fmt.println, let's see what happens. If you will carefully see, then in the string range loop, in the string range loop, you are able to iterate over 0, 1, 2, 3, 4, 5, which is kind of very similar to iterating over the indexes of this particular string, right? So range is kind of like doing a few extra thing here. Right now you might be thinking that, okay, apart from the index of a string, if you want to also get a character, how can you get that? So if I say I comma char, I comma char, so in the first value it store the index of the character, and in the second value it store the value of the character. The moment you run it, you can see you are getting kind of like the ASCII representation of that same character. The moment you have ASCII representation of that character, that means you have the character. How can you actually see the character? We'll talk about that after some time when I will talk about how you can do string formatted printing. But my point being that range is kind of like an operator that is like keyword that is available here, which is going to help you to iterate on a range of values. These range of values are not just limited to numbers. It can be on some data structure, like you can iterate on a range of let's say a array kind of like a thing, or maybe a string kind of like a thing. But this is also something that we have very commonly written in Go. Now one question can come to your mind is, what about while loop? Do we have a while loop in Go? Interestingly not. You don't have a while loop in Go. If you want to do a while loop, the while loop works with for loop only. Let me show you how. So let's say you have a variable j starting with 10. You can say for j greater than 0, and you can say fmt dot println while loop iteration j, and you can do j minus minus. The moment you do that, this is an equivalent of a while loop. Below is a while loop using a for loop. That's what you can say. So Go has a for loop only that can work like a while and for both. This kind of like reduces the confusion as well. So if you want to have the traditional for loop, you can have that. Or if you want to use a for loop like a while loop, that also can work for you. The moment you do that, you can see you have the while loop iterations also properly coming up, right? Interestingly, if you want to have an infinite loop, you can have that. So for this, and the moment, let's say if I execute this statement, this is going to be an infinite loop. And if I don't break it manually, it will keep on going. But if you want to break a loop, you have a break keyword. Very similar to the break keyword available in other languages, you have a break keyword. Also, like for example, if let's say you want to do something like this, I'll talk about conditionals in a minute, right? But if you want to say, let's say if I double equal to 3, and then let's say if you want to do something like continue, let's say j double equal to 3, my bad. So you have a continue keyword as well. What continue will do, it will make the remaining part of the current iteration skip and make it go back to the for loop. So before you do continue, you have to do j minus minus. If I don't do j minus minus here, then what will happen? This will also become a infinite loop. Why? Because let's say the moment the value of j becomes 3, it will come to this if check. if I don't do this j minus minus, it will continue. I'll again go to the for loop. Is 3 greater than 0? Yes. It will again come to this if check. Is 3 equals to 3? Yes. Continue, and so on. This will keep on continuing. So if you won't do this j minus minus here, this will also make eventually a infinite loop. So my point being that you have similar constructs of continue and break that you have in other languages with Golang as well, right? And this also helps us to get introduced to something like if else, right? So if you want to have an if conditional coming up, this is how you can have a if conditional written in front of you. You can use the keyword if, and then you can put a condition. For using the condition, you can use this comparison operator. If you want to see what all operators you have, operators in Go, let's see if we have some shorter tutorial on this. So you can see there are a lot of operators very similar to operators in any other languages. You have arithmetic operators, plus, minus, divide, multiply, modulo, comparison operator, greater than, less than, double, equal to, logical operators, and or, bitwise operator, bitwise and, bitwise or, assignment operator, equals to, and so on. So if you see, you have equals to, plus, equals to, right? All of these are your assignment operators, very similar to how you have in Java or JavaScript. If you want to see, let's say, bitwise operators, these are all of your bitwise operators available. If you want to see logical operators, these are all the logical operators. Interestingly, the logical operators here are very similar to that of, let's say, JavaScript or Java, right? And arithmetic operators are these. You can see similar type of arithmetic operators also you have. So similar kind of an operator arsenal you have in Go as well without any issue. And this is how you can technically compare two values altogether. Now, similar to what you have with if, similarly, you can also put an else, right? So this is how you can put an else block. This is how you can put an else block, right? And if you want to have an else if, you can also do that. So if you say else if, and then you can put a condition j double equal to 5, then let's say we just print skipping 5 and we just say j minus minus, and let's say we say continue. Okay, something like this. Now, let's see why this is failing. Did I miss something? Expected statement found else. Okay. In if you just put an else if like this, if you see, if you try to run the code, you can see it will start considering it an else. So in Go, you have to also keep one thing in mind, that because you don't have now semicolons and all here, so you have to kind of like be a bit more strict with the way you are writing the language. Your else if should kind of like start with the ending with the same line where your if block is closing. Same thing with your else. Same thing with your else. Your else will start from the same line where your curly brace of the other line is ending, and so on. So I can technically put it here. Okay, there you go. Right. So this is how you can put if else along with all of your I would say loops. Interestingly, there is no constraint of indentation, although the linting tool that I've installed in VS Code is automatically re-indenting it, but there is no uh, strictness on the indentation like Python. You can write however you want, wherever you want. Now, there are few more constructs here and there that you will find with Go. For example, you have switch cases in Go. I don't want to go too much into switch case and all, right? This is how you can put a switch case, very similar to how you put switch cases in other languages, right? So you have again cases and a default block. That is something that you can have easily. The more interesting construct that you have in Go is kind of like the concept of arrays. So arrays demo. Okay, and interestingly, you already know how to write functions, but we'll come more into more details of functions. So I'll call arrays demo from here. Okay, so how can you technically create arrays? Very simple to create arrays. Again, you can create an array using the var keyword. So you say var arr1, then you have to give the type. So how you give the type of an array? You first of all put a pair of square brackets, then you give the type of what type of values will go in a array. Now, interestingly, you have homogeneous arrays here. That means you can only put one type of a value in your array. It cannot be like your array has like strings also, booleans also, etc. Those kind of constructs are not going to technically work here. The moment you do this, you can see you have technically declared a empty array of integers. Now if you want to also fill in some values, let's say you want to, let's say, fill in the values. Now here you can put something like this: 1 2 3 4 5. Now you can see what is the problem. It's not able to allocate that, okay, this is going to be an array. It's not able to understand that this is going to be an array. So what you have to do, you have to put first of all a pair of square brackets here. You have to put a pair of square brackets here. And oh, my bad. So like one way of like declaring, when you are actually declaring the integer only, like when you are actually defining the integer, at that point of time, let's say if you want to do it, you can do something like this. So one way is you define, let's say, something like this: int, and now you have an array of empty integers. This is kind of like array of empty integers. Now let's say you want to add something to this array, right? You want to add something to this array. There are multiple functions available. These functions can actually help you to add things to array. So let's see all the function arsenal available. So functions on Golang arrays, okay, and then we'll see how we can add values to it. So if I go over here, we'll talk about what are slices and all. Let's go with a simpler one, go array. Okay, so okay, no, so I'll directly give you the function. So there is an append function in Golang array. Okay, so you can see, so here you have defined an array, and now you can call an append function, and now you can technically call an append function, right? So in the append function, what you can technically do is you have to first of all give the name of the array. So for example, if you say arr1 is equals to append, okay, you give the name of the array again, and then the number of values that you want to add: 1 2 3 4 5. This is how you can one by one append in the array. And you can say fmt dot println array1 is arr1. Let's try to print this, and you can see you are able to get the array printed. Okay, you cannot sorry, you are able to get the array printed here, as simple as that. Now this is kind of like a slight difference. Now slightly we are going to have a bit difference here. Now if you carefully see this array, we didn't define a size. Okay, we have not defined a size here. We have just said that, okay, this is going to be kind of like an array of empty integers. So this is what go, like go doesn't classify directly this as arrays. Go gives them a separate name called as a slice. So let's see, slice in Go. Okay, slices. An array has a fixed size. So Go says that if you are making an array which has a fixed size, then that will be classified as an array. A slice, on the other hand, is dynamically sized, which is a flexible view into the elements of an array. So you can say when your array becomes of dynamic size, that means now however number of elements you want to add, you can add to it. That's what make it as a slice. Okay, very similar to how you have lists in Python, vectors in C++, array list and vectors in Java, or let's say your normal lists in JavaScript and so on. If you want to define an array, then Go says that arrays are something that are of fixed size. For example, you use the same syntax and then you say 5 int. Now this is technically an array which is of technically defined type, that this is of size 5. So for example, if you try to do arr is equals to append arr 1 2 3 4 5, now this function is now no more going to work. Why? Because you are using append, which is technically going to only take a slice. You can see the append function only takes a slice. Append function is going to only work with dynamically sizable arrays, which is slices in the case of Go. So if now you have technically defined that this is going to be an array of size 5, then in the memory when the code is going to run, it is going to allocate 5 consecutive blocks to you. And now if you have to add values to it, you can add the values like this. Like access the index just like how you access it in any other language. Indexing again in Go is from 0, and then here you can actually add. You were not able to do it here because initially you have not defined the size in the slice. If you have not defined the size in the slice, then the only thing that you can do is keep on appending the value at the end of the slice by expanding the slice, right? And internally it just works just like how other dynamically sized arrays actually work. Now, similar to so now we know one data structure, or kind of like two data structures, arrays and slices. Dynamic arrays are your slices. There is one more data structure that you have, which is called as maps. Okay, maps is nothing but a set of key value pairs, similar to your hash map in Java, unordered maps in C++, or you can say objects in JavaScript. How can you technically make a map or create a map? Let's see. So for example, you create a map like this, where product prices, I'll go with the recommendation from Copilot. I say map, and then you have to put a pair of square brackets and you have to define what will be the type of the key. So the type of the key here is going to be a string. Key is going to be the unique identifier. Outside the square brackets, you have to define what will be the type of the value. So let's say the type of the value is going to be int. Okay. And then you put a pair of curly braces and you can start defining the key value pairs. So let's say iPhone 15 Pro, iPhone 15, iPhone 14, and so on. Right. This is going to be kind of like one way in which you will be able to define your kind of like maps, right? So you can do it like this. So let's remove the var, and now let's print it. So fmt dot println and product prices. Here we go. You can also use var, no problem, but this is also kind of like a good shorthand. Sorry, let's call maps demo. So you can see this is how you can get all of your key value pairs. Now let's say you don't want to define your map. So for example, let's say you have another map. Let's say we call it as custom map, right? And then you don't want to immediately define the values. So if you will try to do something like this, you say map of, let's say, string, you can see this is going to technically throw you an error. Like if you will try to even print fmt dot println custom map, you can see this is throwing you an error. Why? Because this syntax only works if you want to immediately define your map here as well. Like if you, the moment you put a pair of curly braces, that's when it is going to create a map of type string comma string, which is string key string value, and create an empty map for you. You can see now everything technically works here. This is kind of like the first fundamental, or I would say first catch, that you have to keep in mind. Okay, now there is one more function that can help you to make an empty map. So I'll say empty map, which is kind of like a function given from the built-in package called as make. If you call make and you put the type of the map here, and then you print the map, this is also going to give you an empty map. So both of these ways you can actually use in order to create a map. And then if you want to add a value to a map, that is going to be kind of like super easy. How? You can just give the name of the map, empty map, put a pair of square brackets and add a key. So here the key is of type string. We give a key of type string equals to a value, and this is going to add a key value pair. So this is going to add a key value pair to our empty map. The moment we run it, you can see all the key value pairs have been technically added. As simple as that. Now we know about maps, we know about kind of like arrays and all. Interestingly, this is where your range function can again come into the picture. You can go to the key value pairs like this. You can say key comma value, and you can say range of empty map. And here you can print the key value pairs like this. This is going to help you go over the all the key value pairs. So this is also the one of the use case of your range operator, that it can help you go over all the key value pairs of your map. Interestingly, if you come here and you say for I comma value in range of arr1, this is going to go to every index of arr, and in the second value it is going to store the value that we are going to get. So I'll say fmt.println index comma value, and if I come up here, let's see where we called array 1. Here we go. Index 0, value 1, index 1, value 2, and so on. Right? So range operator has a lot of use cases that you will find in these data structures very, very easily. Now, throughout this journey, we have seen multiple times us writing function. So function is going to be kind of like a black box that is going to consolidate a bunch of instructions together. Now, functions can also expect some input and give some output. How can we do that? Let's see. So let's say we are writing a function, check odd or even. Check odd even. Let's say this is a function that is going to take a number and check whether that number is an odd number or even number. As simple as that. So now we have to pass some parameters which will be given some arguments when you are going to call the function. How can you do that? You're going to give a number num, and you have to, after that you have to define the type. So I'll say int. This is the type of the argument that is going to be passed when we are going to call the function. And then you have to give the return type. So for example, let's say for now we don't give a return type, right? And let's say we try to return something. Let's say return 100. What you will realize is that you have said that this function is not going to return anything, but you are returning something. That's bad. So what we should do is we should define a return type. How do you define a return type? If you're returning a single value, you can just say string, something like this. And now you can say if num mod 2 is this, you say even, else you say odd. As simple as that. Okay, as simple as that. This is how you technically define a function. Now, maybe in your function you want to return multiple things. Let's say you want to return a string, and let's say you want to return an int also. What you can do is you can wrap these two return values together, and after the function you can see here you have defined that this function is going to return two things. So let's say int represents some status code. So let's say 0, 1, something like this. Okay, and now you can call this function. So let's say x comma y is check odd even and 10, right? This is what you can actually do, right? And now you can print xy. The number is x. Sorry, let's just print xy. This is unnecessary for now. And also, if you have VS Code and you have the code runner extension, you can also click on run code. This is also going to run the code for you, and you can see we are getting even comma 0 because 10 is an even number. If you pass 11, you will get odd comma 1, odd space 1, as simple as that. Now you try to figure out that, let's say if you have to define a function in which you have to pass variable number of arguments or n number of arguments, how can you do that? Just a hint, it is very similar to how you do it in, let's say, a language like JavaScript. Similar type of a syntax you will find for Go as well. Try to figure that out. Now, here comes the most interesting and one of the most powerful concepts that exist in Go. So, what I believe is that in Go, the existence of pointers is kind of like very good. If you have been somebody who was very familiar to the concepts and very much in love with the concepts of C++, you will find the existence of pointers kind of like a relief in Go. Some people are not that much fond of pointers, so they don't really appreciate it. I really used to love C++. I really love pointers. So let's write a function to demonstrate pointers. Very easily you can get pointers. Let me first of all tell you what is a pointer. Okay. So just like you were having variables and buckets where you can store some values, if you want to define a bucket where you can store address of some other data. So like for example, let's say this is your memory. Here you defined a variable I which has, let's say, value 10. Okay, this is like a normal value that you have technically defined. Okay, now if let's say you want to define a bucket that can store the address of I. Now because I is going to be in your memory, so I will be given some address, right? I will be having some dedicated address in your memory, right? let's say that address is ABC. Okay, for now. Now, if you want to store this address in a variable, you want to store this address in a bucket, then what you can say is that this bucket is storing an address. And if you want to define a bucket like this, you need to have a type, right? Because whenever you want to store something, you need to have a type of it. That's where pointers come into the pictures. So pointers are going to be those types which can store addresses for you. So let me show you pointers in Go. Okay. What are pointers? Pointers are variables, as I mentioned, a bucket that stores memory address of another variable. As simple as that. So if you want to store memory address of some existing variable inside another variable, that's when you can make a pointer variable. So you can say pointer is also a type that can store memory address. As simple as that. Okay. For example, let's say you create a value I as, let's say, 120. Now you want to create a pointer that can store the address of I. How can you do that? You can say var ptr. Var is going to be the keyword that can help you to say that we are declaring a new variable. Ptr is the name of the variable. And then you have to define the type. So as I mentioned, the type here is going to be what? Pointer. The type of the bucket ptr is going to be a pointer. So now you know that you are going to store the address of a variable which was an integer, right? I was an integer. So I'm going to store a variable of address I'm going to store the address of a variable which was of type integer. So you say star int. This is going to technically define a bucket which can store the address of an integer. This pointer can store the address of an integer variable. If you were storing address of a float, you could have said star float 32, for example. If you were storing the address of a boolean, you could have said star boolean, and so on. The type of the variable whose address you are storing, you can say star that type, and then you can say equals, and you can store some address here. Now technically we need a mechanism to fetch the address of I. We need a mechanism to fetch the address of I. You can fetch the address of I by saying ampersand I. What is ampersand I? Ampersand is an operator that can fetch the address of the variable for you, right? So when you say ampersand I, you are calculating what is the address of variable I, and you are storing that in a ptr. If you want to go with a short form, you can say ptr1 as ampersand I, and it will automatically figure out that you want to store the address of an integer variable. So you can see the type is automatically inferred, and then you can print it. Value of I is this, pointer to I, pointer 1 to I, and let's put this demo pointers. Save it. Here we go. And you can see value of I is 120, and this is the address of I. And can you see the address of I in both the variables are same, because I'm just fetching the same address of I and storing it in two different variables. This is how the address is looking like, right? So that's what pointers are. As simple as that. So whenever you want to store the address of a particular variable inside another variable, that's when you can use pointers. Now, what you can do with pointers is that if you have the address of a variable, now let's say you have the address of I in this variable ptr. Let's say this is the variable ptr. So inside ptr you have the variable of I. So using ptr you can get the access of the value of I. How? Let's see. So if I say fmt dot println value present at pointer, right? And then now you want to access the value present at the memory address stored in your pointer. You can do that using star ptr. Exactly same how you used to do it in C++. And you can see you are able to get 120. So if you want to fetch the value stored at the memory address you are storing in your pointer, you can do star ptr. This is what you call as dereferencing a pointer, right? That means you want to access the value of the memory address that you are storing. As simple as that. For example, you can say that pointer is like a key to a home. let's say you have a friend and your friend is going on a vacation. That friend gives you a key to his home. That key is like a pointer. And now if you want to see what is, let's say, what he has stored in his home, what kind of furniture he has in his home, what you have to do, you have to take that key and go to that home and use that key to open that home. That's what a dereferencing here is, that you were having access to his home with this key, but now in order to go and see inside his home, you have to go to the home and open it with the key. So same thing here, we were storing address of I in ptr1 or ptr both. Now if you want to see what is present in I, either you can use I, or you can use ptr and you can call star ptr, which is going to actually go to the memory address of I and see what is the value present at the memory address of I, which we are technically storing. That's how you can actually play around with pointers. Now we know about all the basic types available in Go, like, but whenever we have to do any kind of like a development, what we know is that we have to make kind of like custom type definitions, which are going to actually help us in order to make sure that uh, we are able to customize, like, let's say something like a custom class, right? For example, in languages like Java, JavaScript, Python, C++, we have things like classes, right? They actually help us to define a real life entity, right? It helps us to define a blueprint of a real life entity altogether, right? So that is what uh, Go also supports. But in Go, you do not have classes, right? In Go, you have something called as structs. So if you come from the world of C, C++, you must be already aware about structs. You can say structs are very, very similar to that of a class, just like how you group different types together and form a real life entity using classes. Similarly, Go has structs, which is kind of like a collection of these properties and fields. If let's say you want to create a product entity, then you'll be actually creating a product struct, okay, which will be having the name of the product, price of the product, so on and so forth, right? So that's how you actually make structs. So let me actually show you on the official website. So you come up here and you search for Golang structs, okay. So if you come here, you can see this is how you actually define struct. So I'll also show you how you can write structs, but just for a reference, this is how you can actually define structs, okay. And what you will actually realize is that structs is also going to do the same thing that you are doing with classes. It's just that the way in which you are going to add data members and member functions is going to be a bit different. Data members can be directly added, but member functions are not added like this. There is kind of like a different way in which you actually add member functions to structs. We are going to see all of that, right? Now a question can come to your mind is that, like, if that is the case, then will we be able to follow solid principles and all? Yes. Like, if you know about solid principles, then you will realize that they actually help us enforce a couple of clean coding principles, right? So in Golang also there are other properties. For example, there is a concept of interfaces and all also available that can actually help you to, I would say, implement solid principles in a pretty fine way without much of a, I would say, effort. So let's see how you can actually define one of your structs. Okay, so for example, I can maybe come here because I'll comment out all of these things so that we can have a cleaner console. Okay, and now how can you define a struct? So in order to define a struct, you have to write it something like this. You say type, and then you give the name of the struct like product, and then you give the keyword struct, and in a pair of curly braces you actually define all the properties, or I would say the data members along with the types. So for example, there is going to be a name of the product which is going to be of type string, right? There is going to be a price of the product which is going to be of type int. There is going to be a company of the product which is going to be of type string, and so on. This is technically how you have defined a new, I would say, entity definition, or I would say blueprint definition of something like a product. Okay, now interestingly, now let's say if you have to start defining a brand new object out of it. Now eventually, why do you need these blueprints? Because you would like to have real life objects that you can actually create out of it, right? That's what the main necessity is. So for example, let's say you want to create a new product. How can you do that? You will write the name of your struct. So you'll say product, and here you'll put a pair of curly braces, and here you can put kind of like key value pairs. So you can say, let's say, name iPhone 15 Pro, price 1000, company Apple, right? This is a syntax that you can use in order to create a new product, right? And if I say fmt.println, product name is p.name, for example, if I do something like this and I try to run the code, you'll see the product name is coming as iPhone 15 Pro. So this simple syntax is kind of like an equivalent that you do in other languages, like let's say JavaScript, Java, you say new something. Here you do not have a new keyword, you just directly write the name of the struct, you put a pair of curly braces, and then inside the pair of curly braces you put a key value pairs, and that is it. That's how you can actually create a new product altogether, right? Now interestingly, what you might notice is that there is no constructor function that we have defined. If you see, contrary to other languages, in most of the languages either there is kind of like a constructor, kind of like a default constructor available, or you are given opportunity to define your own constructor. Okay, here you do not have a direct constructor function like concept available, right? If you want to create a new object, you directly create it like this. But don't you think, if everywhere I have to create an object like this, then I won't be able to enforce any kind of rules. Like if let's say in a constructor, if I have to define any kind of rules, I won't be able to do that. That's when you can actually define your own function that can act as a constructor for you. So in most of the Go code bases, what you will realize is that people define a separate function which mostly act as a constructor, right? So for example, if I write a function func new product, okay, let's say I'll define a function new product. Now what I want this function to do, I want this function to actually take a couple of parameters and create a new object out of it. So first of all, let's define a couple of parameters. So let's say we are going to define a name string, price int, company string. Okay, these are the couple of parameters that I have actually defined. Okay, now what I would like this function to do, I would like this function to create a new object for me. So let's create a new object. How do you create a new object? You can say p product and then give name, price, company, right? This is capital P product. As simple as that. Now what we would like to do is, we would like to actually return this particular object. Now if I will just do return P, okay, let's say if I do return P, right? And here let's say if I define a return value as product, as of now this function, if you see this particular function, this function very closely resembles something like a constructor, that it takes a couple of parameters, it creates a new object for you and returns that particular object to you. But here this is returning a copy of the product. So this is a new concept that you will realize, that in Golang, when you actually return a custom object which is a non-primitive, okay, when you actually return a custom object which is a non-primitive, then just like other languages, it's not like it is going to return you the same object. No, what Golang is going to refer is, if you write something like this, it's not going to return the same P object, it is going to return a copy of it. Similarly, whenever you are going to pass a custom object to a function, like normally, like for example, if I write a function, let's say if I write a function fun and I normally pass a product P, then this P is a copy of the product that is passed to a function. So whenever you are going to pass any product object here, what you will realize that it is passing a copy. Let me show you what do I mean by passing by copy. Okay, So let's say this is the product you have. Then let's say this is a function fun. Inside this function fun, what do? You change the name of the product. So you change the name of the product to, let's say, MacBook. Okay. This is the only thing that you do. And let's say I call this function fun here. Okay. And then I again print product name after function call. Let's see what happens. If I run the code, what you will realize is that before the function call, the product name was iPhone 15 Pro. After the function call also, the product name is still iPhone 15 Pro. But what you will think is that you passed a product object here and you were trying to update the name of that product object. So ideally this should have come as MacBook Pro, but that's wrong. That's not how Go thinks about memory management. Go says that if you have an object and you are passing that to a function like normally, this is going to actually pass a copy. This is going to create a copy of the product P that you have here. And then whatever manipulations you are doing in this particular function is actually happening on that particular copy. This is not your original product P that you have created here. So technically, instead of saying it as P, I should say it is a copy of P. This is kind of like a copy of P. And whatever you are doing, you are actually doing that on the copy of P. This is a very fundamental concept here. And the same thing is actually happening in this constructor. Although it's kind of like not going to harm you a lot as of now, but what actually this constructor is doing is it's creating an object and then it's creating a copy of it. Now, whenever you have to return a copy means what? You have to recreate that object. So ideally, when you want to create one single object, you are actually creating two instances, one object here, and then you create a copy of it and return that copy. Although later this object is going to be technically garbage collected, but you are technically putting a double effort. Your Golang ecosystem is kind of like putting a kind of like a double effort for a small thing, right? Now you might think that, okay, why technically it is actually present. So a lot of times maybe you do not want a particular object to be actually updatable, right? You don't want that to be updated in the corresponding function. That can be a good case to actually do a pass by copy. But an even more interesting question is that if returning an object is creating a copy, if passing an object is creating a copy, how can I actually access the same object? Like, I don't want to return a copy. I don't want to pass a copy. I want to return the same object. I want to pass the same object. That's where pointers and addresses are going to come into the picture. What you can actually do is, instead of returning a product instance directly, which is going to return you a copy, you are going to return a pointer to the product. And what do you mean by pointer? Pointer means that it's kind of like a bucket that can store a memory address for you. So from here, I cannot return P. I cannot return P. I have to return the address of P. And that's what I'm going to do. I'm going to return a address of the object P. Now let's see what happens. For a moment, if I just remove all of this, and if I say new P is equals to new product. Okay, iPhone 15 Pro, and let's say if I say fmt.println product name, product price, and product company. Okay, as simple as that. Let's see what happens. What you will realize is that it has created a brand new object for you, right? If you carefully see, it has created a brand new object for you. And now, if you very easily see, new product was called, you created a new product here, right? You actually created a new product here. And you actually return the address of that particular object. That means, what is new P? New P is not a product. New P is actually a pointer to the product that you actually created, right? And if new P is actually a pointer to the product, now let's see how we are able to access it, right? If you carefully see, just like how you would have accessed a normal object, right? Normally when you were doing p.name, you were getting a name, right? Here also, if you see, what we are doing is we are doing new p.name, new p.price, new p.company. And if you see the console, you are still able to access the same thing, right? Sorry, if I run the code again, what you will see is that you are able to kind of like access everything in the same way. This is kind of like a syntactical sugar that Golang actually provides you. That if you are trying to access an object and its properties directly, you can use the dot operator. And even if you have a pointer and you want to access something through the pointer, right? Let's say you want to access the value of the data members through the pointers, then also you can just directly use the dot operator. So if you're somebody who is coming from the world of C++, what you might have seen is that you might have seen an operator like an arrow operator, which is generally used for dereferencing, kind of like a pointer, but we do not have to do that here. Even if you have a pointer and you do a dot operator on that pointer, it will automatically dereference your pointer and give you the corresponding object access, and then on that object you will be able to access the data members. If let's say you do something like this also, let's say you want to do something like this, let's say you say star new p dot name. This is also a way to actually do dereferencing. Let's try to run the code. You can see we are getting the same output. So if you manually do dereferencing like this, or you just allow Go to automatically do the dereferencing, both are going to give you the same output. It's just that the syntax on line number 29 is much more modern, much more inconsistent with other languages as compared to the syntax on line number 28, which is much more consistent with something like C++. So most of the people actually feel more comfortable in just doing pointer dot something to actually access the property as well. And now what we have here is, this is not a return by copy. This is a return by kind of like reference. That means you are actually referencing to the same memory object. And in a same way, now, if let's say you have to update this function to actually start consuming things instead of a pass by copy, you want to write this function, or I would say a different version of this function, which is pass by reference. So fun pass by reference. Okay. So instead of passing a product directly, you are not going to pass a product, you are going to pass a pointer to the product. And now if you make a change here, p.name is equals to MacBook Pro. Let's see what happens now. So from here, I'm going to call fun pass by reference, and I can pass the pointer. Can you see? I can pass the pointer to the product, and new p is already a pointer. So I can just say new p, and then I can print again product name after passing the reference. Let's see. If you run it, you can see the product name has actually changed. So this is now no more creating a copy for you. This is actually updating the same object that you returned from your constructor. So this is how you write a constructor, which is kind of like the most efficient one, because you are not creating double objects. And then if you have to, let's say, update anything on the object, if you want, or if your use case says go with pass by copy, you can do that. If your use case says go by pass with reference, the below function actually represents pass by reference. Now we know how can we make structs, right? Now ideally what we should be able to do is, we should be also be able to define, apart from the constructor, we should be able to define some member functions for our, I would say, objects, right? So let's say I want to define a member function, which is kind of like a display, right? I want to define a member function display. So how can you define a member function display? First of all, it's a function. So again, you have two choices, that you can define that function with pass by value or pass by reference. Again, you will do pass by value, which we also call as pass by copy. Then it will create a copy of the object. Again and again, creating copy of the object might also harm your memory, right? Sometimes, because you are again and again creating copies which might not be necessary. So ideally, a good way would be to only use pass by reference, at least for the member function, until unless you have a use case for pass by copy. Okay. This is just going to give you kind of like a more granular control, if you ask me. So now how can you define a member function? So to define a member function of a struct, right? The syntax looks slightly a bit different. Let's see how it looks like. So you say, first of all, func. Func means it's going to be a function. Pretty simple, right? Then you put a pair of parentheses. Inside these parentheses, you actually give kind of like your object name with which you are going to refer that object. So I'll give the object name as P. And you take a call that would you like to pass a copy of the object, or would you like to pass a reference? Hence, you have to pass a pointer. So let's say we go with pointer. And then after this pair of parentheses, you give the name of the function, let's say display. display, right? And then let's say you define the return type. Let's say return type is, let's say, kind of like nothing, so you don't have to separately write void. If you don't write anything, it's kind of like void only. And that's it. That's it. This is a member function for your product, right? This is a member function of your product. And now here you can say fmt.println product details are product details, right? And let's put it like this: name, price, company. Okay, something like this. This is kind of like a member function, and you can see slightly bit of different syntax you actually got from here, right? It's kind of like a different syntax that you have got from here. And now if you have to call this particular function, you can say, just like how you call any other member function in any other language, new p dot display. Here we go. Now display, it is going to be actually called with new p as a reference. So wherever you are going to use this variable p dot name, p dot price, p dot company, this p actually refers to new p. This p is going to actually refer to your calling context. Calling context is new p. Let's try to run this code. So clear the console, run it, and you can see we are able to get all of the corresponding details. If let's say, if let's say you want to pass a variable to the function, like you want to pass some custom variable. So let's say if you want to pass a variable short, which is kind of like a boolean, which is going to represent that I want a shorter version of the display. So let's say if I say if short, then I'm going to just say product.name, product.price, and I'm going to just return. That's it. So from here, you can actually pass a false. False means you don't want a shorter display, you want a complete display. And you can see you are getting a complete display. If you want a shorter display, true, run it, then you can see you are getting a shorter display. So if you want to pass some corresponding, I would say, parameters, you can pass all of those parameters here, just like how you pass a parameter to a normal function. This particular extra addition to the function definition actually represents that this display is kind of like a member function to a struct. So this display function can be called with some particular product object as a reference. That means if you try to just directly call display, if you just directly call display with, let's say, true, you can see this is already throwing you an error that you do not have a display function defined, because this display is now no more a normal function. It is kind of like a member function to the product struct. So every time when you have to call display, you need to have a product object along with you. So if I just close this terminal and if I just show you these three things, this is how typically your class counterpart, which is kind of like a struct here, is defined in Golang, right? This is kind of like your class counterpart. This is how ideally you have to define your custom entities. First is you have kind of like a struct here, right? Let's say, let's put it like this. So you first of all give this as the struct definition. Okay. Then here you actually give a corresponding constructor, and then this is how you can define a member function. As simple as that. This is again, you don't, if you are coming from a different language, you don't have to bang your head and thinking about why Golang is just doing it something like this. For now, you can just say that okay, this is just another way of doing whatever you have been doing as of now. The important concept is not how you write a struct. The important concept is that you have objects that can be passed by copy or passed by reference. So whenever you are going to do development, you will see this concepts being slightly a bit more heavily used rather than focusing on the syntactical sugar of defining a struct. Now, just like other languages like Java, TypeScript, these languages very heavily use the concept of interfaces because they help them to implement polymorphism at some instant, right? Now, what you will realize is that even Golang has its own way of defining interfaces. The moment you have interfaces, that means you can define contracts, right? And contracts, like how you have defined in Java or TypeScript, the syntactical sugar is kind of like a bit different, right? um, you will not find it very similar to like using implements or similar kind of like a concept in other language. It's slight a bit more different syntactical sugar. So now how can we define interfaces? That's a important question. Okay, so let's say I define an interface, sellable product. Okay, whatever product is sellable, we write it like this. We say type sellable product, and this time the type is going to be an interface instead of a struct. Okay, this is how you define an interface. This is how you define an interface. Now let's say I define an interface sellable product, and the products which are sellable on the platform, which can be sold on the platform, will implement this interface. We'll see how you can implement the interface, but for now let's have a method in the interface. Let's say buy. We have a method buy. Okay, and let's say this method returns a string. Okay, let's say this is a method buy and this returns a string. If you want to have this buy method as, let's say, just void, you can just skip defining any return type, and this is going to keep the function buy as a let's say void type. But for now let's say we have a string. Okay, so if a product is sellable, then technically that can be bought. So that's a simple interface that I am defining. So this is the definition of an interface. That's it. That's how you define an interface in Golang. But to implement an interface, you do not have any keyword that you can mention with the struct, and the struct is going to be enforced, right? To implement an interface, what you have to do is your struct has to implement all the methods mentioned in the interface. If your struct doesn't implement all of the methods mentioned in the interface, then it will be considered that that particular struct doesn't implement that interface. For example, let me show you. Let's say there are two functions, buy and let's say get discount. Okay, something like this. Let's say there are two functions. What we want interfaces for some kind of a polymorphic type. So what we would like to do is, we would like to be in a position where we are able to kind of like create uh, or I would say access all of the methods of a particular sellable product, right? So let's say if I define a function, right? Function check discount and buy. Okay, let's say I define a function check discount and buy, and this function takes a sellable product, right? This function is taking, let's say, a sellable product. And let's say what we want to do is, we want to first of all get the discount, p dot get discount, and we check if discount is greater than 30, then we say that fmt dot println discount is good, buying the product, and we are going to, let's say, call p dot buy. Okay, we are going to call p dot buy, and we are going to return. Else we are going to say discount is not good, not buying the product. This is, let's say, the function check discount and buy. So if you have this function, then you want this function to always accept an object which is of type sellable product, or which implements the interface sellable product, right? Now if let's say I go here and say check discount and buy, and if I try to pass new p, what you will realize is that it is throwing me a compile time error. That new p is an object of struct product, and the struct product does not implement sellable product. Why it does not implement? Because it has missing method implementations. It has missing method implementations. Okay, so what do we need to do? We need to define these particular methods like member functions. Like we have to, just like how you override your methods in your classes while implementing an interface, here also we have to define member functions. So the first member function, let's say we are going to define, is buy, which returns nothing, and we can say buying the product. That's it. This is the simplest buy implementation that I can think of. what you will realize is that it is still throwing an error. Why? One second. So this should not return a string. It should be just like this. Okay. Now you can see this is throwing still an error because it has still one method not implemented, which is get discount. So as of now, your struct product is implementing a method buy, but it is not implementing all the methods of sellable product. Hence, product struct is not implementing your sellable product. So you have to override the second method as well, that is get discount. Okay, so for now, let's say I just say discount is defined as, let's say, 20. Okay, or let's say we can put some algorithm in place that discount value is going to be equal to, let's say, p dot price, and let's say 20% of the price is going to be the corresponding discount. Okay, something like this. Let's just have random algorithm. Okay, so now the moment I implemented the second method, and you can see it's not like you just implement a method with the same name. Your arguments and all should be also same. Here we don't have an argument, but at least we have a return type. So the signature of the get discount here is same as the signature of the get discount in sellable product. So the moment your struct implements both of the methods that are defined in the signature of the interface, you will realize the compile time error is gone. The moment the compile time error is gone, you will be able to check the discount. Discount is good, buying the product, and you will be able to kind of like buy the corresponding product. This is how you implement an interface. That in order to implement an interface, what we have to do is you have to just implement all the methods with the same signature in your struct. The moment you do that, your struct is now compatible with that particular interface. As simple as that. This is how Go defines interfaces and helps us implement for purpose. So now let's say we are going to implement a new struct altogether, which is going to be kind of like a simple complex number struct. And for this activity, I would like to maybe, let's say, create a new file. I'll call it as complex.go. Okay. Now, in the start, we are going to write things like package main. Okay. You'll get more clarity around packages later. And for now, we'll define a struct complex. Okay. And I'll define a constructor func new complex, right? And this is going to return me a pointer to the complex object. How will we create a complex object? So let's see. So what we are going to do is we are going to technically have a real value. Sorry, we have a real value. Let's say float 64 and imaginary value float 64. Okay. And when we are going to create a new complex, we are going to get, let's say, a real value float 64 and an imaginary value float 64. And here we can say, let's create a new complex object and then put real and imaginary in place. Okay, as simple as that. Now, of course, we can have only one main function here. So let's come to our main function here. I'll again comment out everything. Okay, let's see a few things in action. Let's see a few things in action. Now, what you will realize is that we have our, I would say, implementation in a different file altogether. Although what we have done is we have tried to define that in the same function, same package, right? We have tried to define that in the same corresponding package, but it is available in a different file. Okay, so let's see what happens in this kind of a case. Let's say if now I try to call C as new complex. Okay, and let's say I pass 1 and 2, and let's say if I say fmt dot println complex number created, complex number is C. Okay, let's say something like this. Now the moment I write this, line, if you see, there has been nothing specifically extra that has been added here, right? Nothing extra has been added here, no import statement or anything. Why? Because this is technically present in the same package. Okay, but let's see what happens when you try to print it, and we'll see a few more operations. Okay, can you see it says undefined new complex? So let's say for a minute instead of saying new complex like this, if I say capital N new complex, and here also if I make capital N new complex, right? Let's see whether it works or not, just for a test. If you run this code, this still says new complex like this doesn't work. Now, why I showed you this implementation? In Golang, there is a couple of ways in which you can work on the visibility part of the things. One of the ways is that if, let's say, things are present in a different package, if things are present in a different package, then what you can do is you can try to name things with starting with a capital letter, and that will become kind of like public and become visible to other packages, right? It will become visible to other packages. If you have functions and properties starting from small letters and this old implementation is present in a different package, let's say a app package or let's say services package, for example, then it will not be technically visible to other packages outside. So let's see, for example, for a moment, let's say if I define it as package app, right? Let's say if I try to define it as package app, okay? So what happens is that it says found package app and main in the same folder in the Go basics. So the first thing that we should technically try to do is, let's say we have a app package going here. We'll move our complex.go file here. The moment we moved it to a different folder, you can see that that particular package error is gone. That particular package error is gone. And now what we have defined is we have defined a different library that in which we have defined all of this code. Interestingly, now hello world actually throws us an error. What hello world.go is throwing us? What error is this coming up? You must be able to already guess it. That hello world is present in the package main, but new complex is present in package app. It's not able to find it, right? It's not able to find it. So if you hover on this, it will say undefined new complex. Now VS Code is also throwing an error because it's a kind of like a compile time issue here. So what we have to technically do is we have to import our app package. This is something that you have to keep in mind. App package is kind of like a different library, right? You have to technically import that. How can we do it? Let's see. So you can say import, and then you have to give the path. So let's say you give the path as app, okay? And then to this import, let's say you can also give a name that we are going to refer this import as app, okay? Okay, and then what you can try to do is here in new complex, right? In new complex, let's say you can try to call it as app.new complex. You can see the moment I say app.new complex, this error is gone and you will be able to come up here. Now this is still throwing an error, and if you carefully see, my editor has already made some adjustment in the import statement. So this is kind of like a shorthand in Go, that instead of writing separate import X, import Y, import Z, what you can do is you can club all the imports in a pair of parentheses. You can club all the imports in a pair of parentheses, right? So you can see the problem here is that it is not able to find the app package, right? That's because of issues with the path. Let's say the moment I say, for example, if I say dot slash app, the moment I give the proper path here, the moment I give a proper path here, that error is also gone. And if I scroll down here, you can see we are able to find this as well. Okay, cool. Now let's see whether we are able to run the code or not. Okay, so let's try to run our hello world.go file. Can you see? This throws us an error. That app is relative, but relative import paths are not supported in module. So what we have done here is we were able to resolve our import. We were able to kind of like resolve our import, right? But the problem that this technically generates is that this is a relative path. This is a relative path. Relative means that when you are sitting inside hello world.go, with respect to hello world.go, where exactly the complex, or I would say the app package, is technically present. That's what relative path is. In relative path, what will happen is you generally try to actually give the path, but by looking at with the reference frame of the current file, that looking at the reference frame of hello world.go, where exactly complex.go is present. So how can we resolve that? It says you should not give relative path. That means what we can do is, instead of saying it like dot slash app, how about how about we say it like, let's say the folder name, which is, let's say, go basics, for example, slash app. Okay, something that like this we will also try to give. Again, you can see this is actually throwing us an error, right? And if you will try to run this code again, this is again saying the same issue, that go basics is kind of like not a package, it is just a normal folder. So what is technically happening with us here is that we are trying to make a multi-file kind of like a project. We are trying to make a kind of like a multi-file project. In this kind of like a multi-file scenario, we need a mechanism with which we are able to kind of like define every single module separately, right? And what Go says that if you want to do it, if technically want to have a multi-file project implemented in a simpler way where you do not have to care a lot about paths, all of that, right? What you can do is you can make your own Go module. And how can you make it? So there is something called as Go mod. Go mod. Let's try to read about it. Okay. Go.mod file referencing. Each Go module can be defined with a different go.mod file that describe a module's property, including its dependencies and all. It's kind of like how you define a package.json file in, let's say, Node.js. Similar to that, you can define a go.mod file. And this go.mod file can actually help you define a dedicated module. And in our case, a dedicated module can be Go Basics. And then with respect to Go Basics, you will be able to give all the other module path. Okay. So let's try to do that. Let's try to do that and see it in detail. So I'll go one folder out, and let's say I'll create a new folder, Go mod demo. Okay. And we'll, sorry, mkdir Go mod demo. And then we'll move our complex number implementation here also. So I'll say cd Go mod, sorry, cd Go mod demo. Okay. Now, how can you create a new Go module? How can you create a new Go module? You can say Go mod init, and then you can give the name of the module. So let's say you say Go mod init, let's say Go mod demo. Okay. And as simple as that statement is doing, very similar to something what npm init also used to do for Node.js, it has created a new go.mod file. And if you open this in VS Code, can you see? Absolutely plain, nothing very fancy, just that you have a new module, Go mod demo, right? And now let's say if I, let's say, create a new file, main.go, right? This I define as package main, very simple, like regular stuff. And if I define a func main, there we go, right? Now, let's say if I define a new package app and new file, let's say complex.go. Okay, I'll copy all of the code from here. Here, copy, paste. Okay, now you can see you have a package app. Now here inside main.go, we have to import app. How can you import app? You can say import. First of all, let's say if you have to import the inbuilt modules like FMT, you can directly do that, no problem. Now, you can say import, and you can say go, what is the name of the package here? Go mod demo. You say, let's say go mod demo slash app. Okay, what you are saying is go mod demo slash app. Now you can see this package app is now referenced with respect to your complete module. So this complete project that we are defining can be referred as a single module, right? This can be referred as a dedicated single module. Okay. And with this particular dedicated single module, what you will be able to do is you will be able to kind of like interuse all of the files and folders here and there. So you can also give a dedicated name. Let's say you give it kind of like a name app that you want to use in order to refer it. And then here you can say C is equal to app dot new complex, you give a complex number like this, and you say fmt dot println c, and now you can see no errors are actually coming up because you are able to kind of like give a proper path to it as well. Let's see whether it runs or not. And now you can see we are able to kind of like create a new complex number and execute it. And now all of the other concepts that you saw, like for example, if you try to make it new complex like this and you try to access it new complex like this, okay, the moment you try to do that, and let's say you try to import app as, again, sorry, I'm not sure why it got removed, go mod demo, you can see it's again and again removing it because now there is no new complex that you have defined here. It is now no more visible. You can see it says new complex is unused, you won't be able to technically find it. But the moment you bring it back to capital N, here also you bring it back to capital N, save it, you can see it detects everything properly. You run it, you are able to, sorry, you run it, you are able to get everything back. Now interestingly, let's say you try to do c dot real. The moment you try to do c dot real, same problem will come up, that it doesn't know what is real. Why? Because real is a property that you have defined with a small r. The starting letter is small and the package is different, hence you won't be able to find it here. If you want to find it, you have to say c dot capital R or c dot capital I. Same thing here. This is how you define visibility throughout packages. Okay, and now you can say c dot capital R, save it, run it, and you can see you are able to get this. So that is the concept that you need to have in order to build a multi-file kind of like a project. That first of all, you have to, if you want to use multiple files, use multiple packages together, you have to define your own go module. Go module is going to be kind of like a amalgamation of all of the smaller packages or libraries that you are going to create. You can say go module is kind of like a project that you are going to create. And in order to define a module, you define a go.mod file, which you can use, which you can define by using go mod init. It is very similar to defining a npm init file. It is very similar to defining a npm init and defining a package.json file. And then every package can have its own set of implementations coming up. And now let's say for example, we define another file for a moment. Let's say we define a lib.go file. I define the lib.go file in the same package, which is package main, and I define a function hello, which just, let's say for now, just returns a string hello world. Okay, let's say we have a function hello. Now in the main.go file, if you try to, let's say, access hello, let's see what happens. If you try to run the code, you can see it again says undefined hello. It is again saying undefined hello. So now we know how can you access things in different packages. Complex number was present in a different package. Main.go is present in a different package. You are able to access things by importing it like this. Now, how can we use the files which are present in the same package? So what's actually going on here? Let's see that for a minute. Can you see me? You are whenever I click here, play button, it says go run this particular file. Okay. Even if I go to my terminal and if I say go run main.go, what I am doing here? I am only asking this main.go file to be compiled and executed. Now, what Go is going to do is, Go is going to take a look at all the import statements. In the import statement, you have defined this particular package. It will start compilation of this package as well. Right. So for example, if I say go build main.go for a minute, okay, and I'll comment out this hello statement. Okay. If I say go build main.go, okay, you can see it is going to create a executable for your main, right? Now, in order to create this executable, it will see that, okay, all of these import statements are present. These import statements are from a different package, so you have to compile that package as well. This is also a different package, so you might have to compile all of the dependencies of this package as well. What you are missing is, that nowhere we are actually asking Go to also compile lib.go. We are able to find the function. If you carefully see, VS Code is already hinting us that we are not doing anything wrong. There is no kind of like issue in visibility of the hello function, right? Even if you have hello as capital H, or you have hello as small h here. VS Code is already telling us that there is no issue with the visibility. The issue is that we are not compiling kind of like everything. So let's say instead of saying go build main.go or go run main.go, we say go run star.go. That means try to compile each and every single file altogether and run it. Now you can see we are able to execute the code, and hello returns us a string. So let's see whether we are able to get that string or not. If I say go run star.go, hello world 1. So this is kind of like an important thing that you have to keep in mind, that in Go, or let's say in most of the compiled situations, it can be tricky to actually make sure that you are compiling each and every single file. And when you're not kind of like compiling each and every single file, then these kind of issues around visibilities can actually come up. And in fact, let's say, for example, let's say I create another file in package app called as temp.go. I say package app. Okay. And let's say I have something like a func new, right? A new function, something like this. And let's say for a minute there is a compile time error. Let's say some syntactical issue is there. Okay. Let's say there is some syntactical issue here. Okay. Let's see what happens if I do goes run star.go. You can see, because it is reading the complete app package, it was reading the complete app package, it was able to kind of like identify that complex.go is all good, but temp.go is not good. Why? Because you are importing the complete app package here. So it will be technically responsible to look at all of the files present in the app package, right? This is important. But when you are just using your lib.go, you have that in the same package main, right? But you are nowhere compiling it, and you are not nowhere linking it to the final executable. That is something which is important in compiled languages, that your final executable should have the linking to your other libraries and your other files in the same library as well. So that's what go run star.go actually helps you to do, that whatever files are actually present in the current folder, all of those will be compiled, and then whatever file has the starter, I would say main function, that particular file is going to be technically picked, and from that starter main function your execution of the code is going to start. This kind of a implementation you might not be able to like directly see in a project, because in most of the time what happens is that in a project you generally have a server.go file, and then controllers, services, repository, all are in their same package. Very less number of time you have multiple files in your main package as well. So this kind of a demonstration, a lot of time people never notice, but this is also something that you have to keep in mind, that you have to compile everything and then attach it to the final executable. So now we know how exactly we are able to create a multi-file project now. And now this is a simple function to create a new complex number. Now, if you want to add two complex number, the best way would be that your current complex number is also referred as with reference, and the new complex number is also passed as a reference. You don't create a copy unnecessary unless you have a use case of it. Then you can have a subtract method. In addition of complex number, you add real to real, imaginary to imaginary. In subtraction, you subtract real from real, imaginary from imaginary. Multiplication is a bit different. For calculating the real part of the complex number, you multiply the reals and subtract with the multiplication of imaginary. And to compute the imaginary, you multiply real with imaginary and then add it with the other imaginary with real combination. And then you can have a display function, complex display, and you can see all of these functions I'm making in caps so that we can have kind of like um, visibility outside the package. and we can have a display like this. The complex number is c dot real plus c dot imaginary, and we append a I. I stands for iota, and that's it. This is how you can create a very simple complex number. This is technically your constructor for complex type, and the remaining functions are all of your member functions of the complex number.